So let's get into this idea of factoring. Now, factoring is going to undo the multiplying polynomials that we did in previous videos. So it's going to undo that, okay? And it's going to be a very important concept, and we're going to start off just by talking about the greatest common factor, okay? So what is a factor? So a factor are the quantities or the things, the items that are being multiplied in an expression. So the greatest common factor is the biggest factor that divides or goes into two or more factors. So you're basically looking at what do they have in common. If I'm listing some items, the greatest common factor is going to be what they have in common. So to get into this, let's look at this like the factors of 12. What can you multiply together to get 12? Well, I could do 1 times 12. I could do 2 times 6. I could do 3 times 4. All right? What about factors of 30? What can I multiply together to give me 30? Well, I could do 1 times 30, 2 times 15, 3 times 10, 4 doesn't go into it, and then I get 5 times 6, okay? So we get all this stuff. Now, the greatest common factor is the biggest number that goes into both 12 and 30. So look, the biggest number that goes into both is this 6. So the greatest common factor of 12 and 30 is 6. I'll do it like this. 6 is the biggest factor, in this case the biggest number, because I'm just dealing with numbers. It's the biggest number that goes into both 12 and 30. All right, so find the greatest common factor of the following: 27, 36, and 81. Okay, so we can just list the factors of 27 here. So we get 1 times 27 and 3 times 9, all right? That's it for 27. Now we look to see which of those numbers goes into both 36 and 81. Well, 1 goes into all of those, 3 goes into all of those, 9 goes into all of those. Okay, now does 27 go into all those? So we get 27. 27 times 2 is 54. 54, or 27 times 3 is 81. So it goes into 81, but it doesn't go into 36. Okay, so 27 is out, which means that 9 is the next biggest number that goes into both 27, 36, and also 81. So the greatest common factor is 9, because 9 goes into each of those. Okay? What about when I'm dealing with variables? A squared, b to the third, a to the fourth, b to the sixth, and a, b to the third. So this one works by looking at what variables they have in common. All right, so like in this first factor, I've got a squared. In this second factor, I've got a to the fourth. In this third factor, I've got a. So how many a's do they have in common? Well, this one only has one a to give. So an a. Now, how many b's do they have in common? The first factor is b to the third. Second factor is b to the sixth. Third factor is b to the third. Okay, so what is the least amount that they have in common? What does it have to give? Well, the first and the last factor only have b to the third to give. And then they run out of b's. Okay, so we're looking for the smallest exponent there on our variables. That's what we can pull out for the greatest common factor. Okay, so this is the greatest common factor of all of these is a, b to the third, because that's at most what these factors can give. Okay, now that we've got an idea of what greatest common factor is, let's factor the greatest common factor from the following. All right, now, basically what you're looking for is what do they have in common with the numbers and the variables. And if the leading term, so if the first term you see when it's in standard form is negative, we also have to factor out a negative sign. All right, that's really key. So we got negative 8x to the fifth plus 16x to the fourth minus 6x to the third. And we have to see what is the greatest common factor in the numbers and the variables. All right, so notice how the first thing you see is negative. So that tells me I need to factor out a negative sign. Now we look at the 8, the 16, and the 6. What goes into 8, 16, and 6? Well, the greatest common factor that goes into 8, 16, and 6 is 2. Now look at the variables. We have x to the fifth, x to the fourth, and x to the third. So what is the most number of x's that I can pull out? Well, I can pull out x to the third because that's all that last term can give me. Okay, so the greatest common factor is negative 2x to the third. But when we factor that out, there's still something left over inside the parentheses. Okay, so what I'm going to do is I'm going to divide each of these by negative 2x to the third. All right, and what's going to be left over? Well, negative 8 divided by negative 2 is 4. X to the fifth divided by x to the third, well, just think, we got 5 x's that are being multiplied on top. And we have 3 x's that are being multiplied together on the bottom. Well, things are going to cancel out, and I'm going to be left with x to the second on top. Because we had 5 x's being multiplied divided by 3 x's getting multiplied, so 3 of them are going to cancel out, leaving me with 2. All right, next up we got 16 divided by negative 2. Well, 16 divided by negative 2 is negative 8. And then we have x to the fourth divided by x to the third. So if we have 4 x's multiplied on top and we have 3 x's being multiplied on the bottom, 3 of them are going to cancel out, leaving me just with 1 x on top. And then we got negative 6 divided by negative 2, which is positive 3. And then x to the third divided by x to the third, well, those are just going to cancel each other out. All right, so the final factored form here is negative 2x to the third times 4x squared minus 8x plus 3. Okay, so this is a factor, and this is a factor, because those are the two quantities that we are multiplying together. All right, now look at what's remaining. This is called the remaining factor. So if I look at the remaining factor, look at 4x squared minus 8x plus 3. There's nothing else that we can factor out of that. There's nothing else that we can divide out. So that's how we know we've got our greatest common factor. Okay, so it's going to take a little bit of practice, but you're looking for what they have in common in the numbers and the variables. All right, so let's go on to the next one. Here we got 27y squared plus 14. Well, what's the biggest factor of 27 and 14? What's the biggest number that goes into both 27 and 14? Well, to get 14, we just take 1 times 14 and 2 times 7. Which of those numbers goes into 27? Well, the only one that goes into 27 is 1. All right, so we can pull out a 1. And now we look at the y's. We got y squared and we've got 14. Okay, so we got y squared and 14. 14 doesn't have any y's to give. So the only factor is 1. So the greatest common factor is 1. So the final factored form is 27y squared plus 14. This one doesn't change at all because there's nothing that I can divide out of both the numbers and the variables. All right, we got, moving on to number 3, 14c to the 4th plus 2c squared. What can I take out of both 14 and 2? Well, 2 goes into both of those. And then what can I take out of c to the 4th and c squared? Well, I got to take out a c squared. They have c to the 2nd in common. So then when I divide both of these by 2c squared, I'm left with 14 divided by 2, which is 7. C to the 4th divided by c squared, which is c squared. Plus, notice what happens here. We got 2c squared divided by 2c squared. The same thing on top is the same thing on the bottom. So those are both going to cancel and leave me just with 1. All right, so my greatest common factor was 2c squared, and the final factored form was 2c squared times 7c squared plus 1. And we could always, always, always check this. If I distribute this back in, I'm going to get what I started with. Okay? And then next up we got negative 21a squared plus 22a to the 8th. The first thing we see is negative, so I need to factor out a negative sign. What goes into 21 and 22? Nothing, just 1. So we could factor out a 1. All right, and then what about a squared and a to the 8th? Well, a squared and a to the 8th, this first term has a to the 2nd to offer. All right, so I'm going to get that, and then I need to divide each of these by my greatest common factor. I'll get negative 21 divided by negative 1, which is 21. And then a squared divided by a squared, those are both going to cancel out.
Hey, good morning, Warriors.
Sorry, 1 second. Gotta let Dr. P do his thing.
Please stand and join me for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Hey, why don't history teachers want to teach about the Middle Ages? It takes too many nights. Oh, all right. Have a great day, Warriors.
All right, sorry about that. So now we're back at it. So we divide negative 21a squared divided by negative 1a squared. That's going to be 21. And then 22a to the 8th divided by negative 1a to the squared. 22 divided by negative 1 is minus 22. A to the 8th divided by a squared is going to be a to the 6th. All right, because when I factor out a squared from a to the 8th, there are a to the 6th left over. All right, so my greatest common factor was negative a squared. We can put the 1, we don't have to. So our final factored form is negative a squared and then 21 minus 22a to the 6th. Okay, so we got one more problem here. We got a doozy here. We got 12xy plus 24xy squared minus 30x squared y to the 4th. All right, so what is the greatest common factor of the numbers? 12, 24, and negative 30. Well, the first thing we see is positive, so we don't need to factor out a negative. Okay, so what am I going to do here? So 12, 24, and 30. Well, let's look at 12. 12 is 1 times 12, 2 times 6, 3 times 4. All right, which of these is the biggest number that goes into 12, 24, and 30? Okay, well, 12 goes into 24, but it doesn't go into 30, so that's out. What about 6? Well, 6 goes into 12, obviously. 6 also goes into 24, and 6 also goes into 30. Okay, so I can factor out a 6. So then we look at the x's. We got x, x, and x squared. So the first term has an x, second term has an x, third term has an x squared. So we got to take the least number of x's, all right, because 12xy and 24xy squared only have one x to give. Now we look at the y's. We got the first term has y, second term has y squared, and third term has y to the fourth. So we're dictated to only take out the number of y's that each term can give. And the first term can only give one y. So all I can take out is one y. So that's my greatest common factor. So now I'm going to divide each of these by my greatest common factor to see what the remaining factor will be. So 12 divided by 6 is 2. X divided by x cancels out. Y divided by y cancels out. Okay? The next term, 24 divided by 6 is 4. X divided by x cancels out. Y squared over y means there's going to be one y left over. And then for this last one, we got negative 30 divided by 6, which is negative 5. X squared divided by x, which is just x. And y to the fourth divided by y. So I'm taking one y away, which means there's going to be y to the third left over. All right, so our final factored form is 6xy times 2 plus 4y minus 5xy to the third. And then we're done. There's nothing else we can factor out of that remaining factor. 2, 4, and negative 5, nothing there. There are no more x's to give. There are no more y's to give. So that's how we can always double check our work. And then we can always also distribute this back in. So we get 6xy times 2, which is 12xy. 6xy times 4y, which is going to be 24xy squared. And 6xy times negative 5xy to the third, which is minus 30x squared y to the fourth. Now notice this is the same exact thing as what we started with. If it's not, that's how you know you made a mistake. Okay? So that is factoring using the greatest common factor. That's going to start this process in us undoing multiplying polynomials, which are going to be helpful once we start to solve some equations that you probably haven't seen before. All right, so that's why factoring is such an important skill, undoing multiplication to figure out what those individual factors all are. All right, so I got 2 you try nows here for you. This is a super important concept to practice because we're going to use factoring a lot from here on out. Let me know if you have any questions.